to lesson 3.1, which is properties of quadratic functions. Again, we're going to be reviewing some information from grade 10, but we might build on to it a little bit in terms of the transformations that we discussed in unit 1. Let's take a look here at our warm-up question. So we've got a function f at x equals negative x plus 2 squared plus 6. In every case, folks, I always like to take whatever equation I have and tell me what form it is. So for example, this is the vertex form. Okay. And what important information does the vertex give us? It gives us the vertex, which is negative 2 and 6. Usually, one of the questions in the problem will be given by that form. And the first one happens to be determine the vertex. So the vertex here is negative 2 and 6. The axis of symmetry, ladies and gentlemen, deals with the x-coordinate of your vertex, and it's an equation, so it's going to be x equals negative 2. The x is because, ladies and gentlemen, it's a vertical line crossing x at negative 2. Direction of opening, again, you look at A, ladies and gentlemen. A is negative, so it's going to open down. Okay, it's down because A is less than 0. All right. Taking a look at our step pattern, we remember that step pattern is A times 1, 3, 5, and A 3, 5. Again, A is negative 1, so you sub that in. I apologize, folks. I didn't leave enough room here. Let me move that up. All right, sorry. Erase. So we've got A times 1, 3, 5. Subbing in A is negative 1 times 1, 3, 5. So our step pattern equals negative 1, negative 3, negative 5. That also confirms that it's down, okay? All right. All right. Taking a look here, ladies and gentlemen, we asked to find the y-intercept. To find the y-intercept, you let x equal 0. So in this expression, you would go f at 0 and solve. So you would plug it in. And what would you find out? That f at 0 equals 2. What that means is that the y-intercept is 2. Our domain for all quadratic functions is that x belongs to a set of real values or real numbers. Okay? Whereas range, there's a restriction based on your min and max. So again, range is that y belongs to a set of real numbers such that, and in this case, y is less than or equal to 6. Okay, this may be easier to do after we graphed, and that's okay. I'm not sure. It doesn't matter to me what order you do in. But just remember, you look at the information given. Direction of opening is up. Sorry, direction of opening is down. That means it's got to be less than or equal to. And 6 is your optimal value, which is your y part of your vertex. All right, let's graph this. So I know we did this in the first unit, so let's just review. How are we going to graph this? We're going to take a look at our vertex. We'll start with that. So we'll plot negative 2 and 6, just right here. Okay, and then from that, we're going to use the step pattern, which is negative 1, negative 3, negative 5. So from here, as I go over 1, I'm going to go down 1. In both directions, as I go over 1, I'm going to go down 3. 1, 2, 3. And what you notice when I go over here and I go over 1, down 1, 2, 3, I actually get that point I've calculated, which is your y-intercept. Okay? Don't forget, ladies and gentlemen, to write the function down. So this is f at x equals negative x plus 2 squared plus 6. All right, here's our warm-up for today. Now let's get into lesson 3.1, quadratic functions. All right, so what I want to do here, folks, is I'm going to see if I can put some spaces in here, simply because it's easier to deal with A first, because A appears in every one of these formations of the quadratic function. So we're just going to deal with it separately. So we're just going to deal with A first. So let's look at A. Okay, and just remember that A is the same in all three forms. Okay, and we're going to deal with the transformation aspect today, okay? So first of all, A tells us the direction of opening, so that's one thing it does. So direction of opening, okay? So if A is greater than 0, it's going to open up. And if A is less than 0, it's going to open down. You love my parabolas, aren't they cute? All right. That's one thing A does. The next thing A does that helped us in the warm-up with the graphing is it indicates the step pattern. So the second thing A does is the step pattern. Okay, so the step pattern is A times 135. Hopefully you have that memorized so it's easy to graph. And the third thing deals with our translation. Just remember, guys, that A deals with a vertical stretch or compression. So if we have a vertical stretch, A has to be something. What does A have to be, guys? A has to be, so the absolute value of A has to be greater than 1. Whereas we have a compression, a vertical compression, if the absolute value of A is in between 0 and 1. All right, and again, that's from your from above and below. So if you think of your elastic you're pulling, you're stretching either out or in for your stretch or compression with the elastic from your hands being on the top or the bottom of the elastic. All right. Now taking a look at standard form. Standard form has ax squared plus bx plus c, and the important information that it gives us here is that c is the y-intercept. Again, that's a review from last year and yesterday. Okay, but we're going to add on to that. And just remember, guys, that c is also the initial value in words problems, okay? All right. All right, so that's standard form. The next form we're going to take a look is vertex, and we're going to use the transformation form. Okay, so in this case, we have that our vertex is D and C. Okay, and don't forget that x equals D stands for our axis of symmetry. And that C gives us or equals our optimal value. And another word for optimal value, you might be used to just the min or max value. Okay, and that again is part of your restriction of your quadratic as well, if you're taking a look at the range. All right, now ladies and gentlemen, this is the formula that our textbook uses this year for factored form. You may be familiar with the one that we reviewed last day or last year, where it's x minus s and x minus t. But in our textbook this year, and I know that gets frustrating for students, but they just seem to use different variables. It won't be an issue when you have those variables subbed in and you have values like x minus 5 or x plus 6, but they just tend to use a different variable here. So according to our textbook that uses r and s, just remember that r and s are the x-intercepts. Okay, just going to move my screen up here. Okay, another word for x-intercepts are roots. Okay, they could also be solutions. And the last one they could be is zeros. All right, and just remember though, R and S are in fact symmetry points. So if they're sim points, that means that we can use a formula to find the axis of symmetry. So the axis of symmetry, we use the equation x equals, and what you're going to do is take those two values, r and s, add them up and divide by 2. Okay? And once we have that value, the axis of symmetry, we can sub this value into the function and solve for the y part of the vertex and find the y part of the vertex. So then you'll have the vertex, because remember guys, the axis of symmetry is the x coordinate, and then you sub it into the function and you'll find the y. And we'll do an example of that today further on in our lesson. Okay, and just to simply review that when we have a domain, guys, there's no restrictions, so x belongs to a set of real numbers because it's an equation or a function, whereas range, we have a restriction. Okay, so x belongs to a set of real numbers such that, and it depends if you have a minimum or a maximum here. Okay, so it's either going to be greater than or equal to c, and that's when we have it opening, the direction of opening being up, or a is greater than 0, or you can write down a minimum. Okay, whereas down below here, it's got to be less than or equal to if we have a maximum, or it opens down, which means a is less than 0. I'll just put my closing bracket in there. All right. Okay, let's take a look at an example on the next page. Again, please come and see me if you're not sure with any of these terms or what the mathematics I've done here today. All right, example 1. For the function g at x equals 0.5 bracket x plus 3 bracket x minus 5. Again, I always say, hey, what form is this in? So it's factored form. And what does that give us? That gives us the zeros. So I know our zeros are, and it's the opposite of what you see them. So our zeros are -3 and 5. Okay? All right. X-intercepts. To find your x-intercept, you can let y, or in this case, g at x. My fault. Let me get a typo there. Okay, so we can let g at x equal 0. So what does that mean? 0 equals 0.5 times x plus 3 times x minus 5. And you can use the zero product property. Just remember from last year that if the left side equals 0, how do we get the right side to equal 0? That means each factor has to equal 0. So you may have remembered from grade 10 setting up a t-chart and going x plus 3 equals 0, and then you solve for the variable x equals -3. Or you take your second bracket, x minus 5 equals 0, so x equals 5. So our answers here, folks, are x equals -3 and x equals 5. Also, you may have remembered that x-intercept is the same as the zeros, and it was given as an important piece of information in the function. All right, next, ladies and gentlemen, we're going to find the axis of symmetry. So we use the equation x equals r plus s divided by 2. So let's sub that in. So we've got -3 plus 5 divided by 2, which equals 2 over 2, which equals 1. So what does that mean? My axis of symmetry is x equals 1. That's where I have my vertical line being the left side of my problem, or right side, being symmetrical about the line x equals 1. Now we need to do the vertex. To find the vertex, guys, we're going to sub in our value that we just found for axis of symmetry. So we're going to sub x equals 1 into g at x. Okay, so remember, you're going to replace wherever you see an x, you're going to place a 1. So it's going to be g at 1 equals 1 plus 3 times 1 minus 5. And I apologize, let me throw the 0.5 in there. Let me rewrite it. I forgot, sorry. I got so excited about the substitution, I forgot to throw in the a value. So let's try that again. 1 plus 3 times 1 minus 5. Use your calculator or your brain, and you're going to find out that it equals -8. So what does that mean? The vertex equals, we already have our x, which is our axis of symmetry, which is 1, and our y value is -8. All right, direction of opening, you look at A, and A is positive, so it opens up. because a equals 0.5. To find the y-intercept, ladies and gentlemen, we're going to let x equal 0. So it's going to be g at 0. Again, you sub it in. So it's going to be 0.5 times 0 plus 3 times 0 minus 5. Use your calculator and you'll find out that you're going to end up with the y-intercept being negative 7.5. Okay? All right. And if you're wondering what ordered pair that would be 0 and negative 7.5. It's our y-intercept. Okay, domain, again, domain for all quadratics is that x belongs to a set of real numbers. Whereas for our range, we're going to have that y belongs to a set of real numbers such that y is greater than or equal to negative 8. Again, the negative 8 is your optimal value from your vertex. And it's got to be greater than or equal to because a is positive, which means you have a minimum. Okay? And then it says, folks, to graph it. I always like to graph with the information that was given and started, and then I check the information that I found. Okay, so I put x and y on my graph, and I'm going to start with my x-intercepts that were given, which is negative 3 and 5. Okay, and then I want to check when I plot my vertex, which is 1 and negative 8, I want to check to make sure that they are equal, that the vertex is equal distance in between the two sim points, or my two zeros. Okay, and in fact, yes, they are, because I can see if I draw my axis of symmetry, that they're equally spaced from that axis. Okay, and the other important piece of information that we calculated was the y-intercept. Y-intercept is negative 0 and negative 7.5, which is right here. And then if you want to finish off, you can check with your step pattern. So as you go over 1, you go up a half because a is a half. Over 1, up 1. Over 1, up 2.5. Okay, and again, you could do that on the other side. Over 1, up a half. Over 1, up 1.5. And over 1 and up 2.5. Again, draw as best as you can a nice smooth parabola. Okay, and don't forget to label it. So we're going to write it g at x equals 0.5 times x plus 3 times x minus 5. There ends that example. Now we're going to be doing a little bit more practice with completing the square. Okay, so to complete the square, folks, you have to take a look at your initial expression. If you have an equation or a function, then you can do common factoring. But in this case, we don't have f at x or g at x or y equals, so we can't common factor and delete that. So just remember, we're going to do these steps by steps, and the first one's a little easier, but the second one we're going to have fractions, so just have some patience here. So the first step, guys, step 1 is to factor out a of the first two terms. Because remember that 8 is not going to be part of our perfect square, so it's not going to be included. Okay, so let's do that. So we're going to make that equal to 2 bracket x squared minus 6x. All right. And then your plus 8 stays out. Okay? Step 2, ladies and gentlemen, is to take a margin and do b divided by 2, and then you're going to do b divided by 2, and you're going to square it. And this is the number that you're going to insert, which you're going to add or subtract, add and subtract into your bracket. And remember, you want to add it because it's going to complete the square, but you've got to subtract it in order to keep the equation balanced, or the expression balanced in this case. All right, so let's do that rough work in the margin here, folks. So b equals negative 6. If you take b divided by 2, that equals negative 6 divided by 2, and that equals negative 3. And then you take b divided by 2 and you square it. So what does that equal? Negative 3 squared, which equals 9. And again, that's the number you're going to add and subtract inside your bracket. I'll throw that in a different color in just a second. Okay, so you add first and then subtract. Okay, the next thing you want to do is to set up your perfect square. So what I mean by that is I need to get my first three terms, which are these three terms within the brackets, isolated just in the brackets by itself. So what I need to do, folks, is I need to take this -9 and bring it outside the bracket. Okay? So let's create the perfect square inside. Okay? And then what happens when you bring this -9 out? Don't forget, it's affected by a, so you got to times it by a. In this case, a is 2, so it's going to be -18 plus 8. Okay? And then we can finish or complete our square. So that could be the next step. So complete the square. And what you're basically doing, guys, is creating the binomial squared. So you're going to make it look like x plus a or x minus a squared. It looks like that. Okay, so in this case, it's going to be x. So you take the square root of the first, square root of the last, and then the sign of the middle, or square root of the first, and if you've done this in 2 steps in your margin, that value is right there that you're going to put in there, and then you make it the binomial squared. Okay, and you could either do this next step together on that line or do it in a separate line if you like to be more organized. Number 5 is just to collect the constants. Okay, so collecting the constants, I'm going to end up with 2 times x minus 3 squared minus 10. If I asked you for the vertex, you would tell me it's 3 and 10. If I asked for your optimal value, you could tell me that it's -10. And because of direction of opening, you could say that it's a minimum of -10. I could also ask you for the axis of symmetry, and you would say x equals 3. So again, it gives you lots of information once you are in the vertex form. Okay, now ladies and gentlemen, have some patience because we're going to be dealing with some fractions here. Okay, it is not nice when a is greater than b. Okay, so what we're going to do now is we are going to do these same steps, but I'm going to go through them with you. Okay, here we go. So looking at this expression, we're going to factor a to the first 2 terms. So it's going to be 6 times x squared. That's the easy part. But how do you take 6 away from 3? It's actually going to be 3/6, which is actually simplified to 1/2 x. And then again, leave the -7 out because it's not part of your completing the square. All right, here we go, folks. b divided by 2, that's going to equal 1/2. And then you're going to divide that by 2. You could use your calculator here, or you could say, hey, I can invert and multiply, or I've got 2 denominators. A 2 is a denominator and a 2 is a denominator, and you multiply those. 2 times 2 is 4. Okay? So again, you could have taken 1/2, times it by, got to invert and multiply, 1/2, which is going to equal the 1/4, if you're not sure how I got that. And then don't forget, I got to take the 1/4 and I got to square it. So again, exponent law says you multiply the numerator, so 1 times 1 is 1, and you multiply the denominator by the exponent, so 4 squared is 4 times 4, which is 16. This is the number I'm going to add and subtract within my brackets. Okay, so here we go. So I've got x squared plus 1/2 x. I'm going to put it in just a second in a different color, just for those who are trying to find on the lesson. So you're going to add 1/16, and you're going to subtract 1/16. Okay, again, we're going to collect the first 3 terms in there. That's going to make our perfect square. So we are going to write 6 out front, x squared plus 1/2 x plus 1/16. And then when you bring that -1/16 out, don't forget you got to times it by 6. So that's going to be -6 over 16, subtract 7. Okay? What I notice here, guys, to make life easier is I can reduce this fraction. So 2 goes into 16 8 times, and 2 goes into 6 3 times. I'm just making life a little easier. All right, next step, I'm actually going to complete the square, which is going to be x, and then I'm going to go plus 1/4 squared, and then I still have to collect these like terms. So I've got -3/8, and again, when you're subtracting or adding fractions, you need to have a lowest common denominator. So I've got to make this out of a base of 8, which means -7 times 8 is 56. Well, the negatives subtract. Okay, and then we're going to simply collect like terms. Okay, so here we go. Okay, so when we simplify this, we have -59/8. I apologize for the announcements in the background, but let's just take a look here. What do we have? A vertex of -1/4 and -59/8. Okay, and basically you have a minimum because it opens up of 59/8. Okay, if it was a word problem and that was a distance, they might ask you to say what's the initial distance, or sorry, what's the maximum height or whatever that got reached. Then you might have to change that to a decimal. Okay, I would appreciate you leaving it in fractions. Here's a general rule of thumb, ladies and gentlemen. If the question is given to you in whole numbers, then keep it as fractions. But if your question starts as fractions, then by all means, you can use fractions to complete the square. I know if you deal with physics, ladies and gentlemen, and you do the acceleration due to gravity, you're going to have -4.9 or 9.8 as common values to start with when we get into the word problems. All right, so ladies and gentlemen, again, completing the square. If you need some more practice, you can check the appendix in your book, as well as practice some of these questions here. So here's your homework, page 145, 1 to 4, 5 to 8, 9, and try 12. Have a great day. Sorry for the announcements.